Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in this lecture. In past lecture, we completed our heterocyclic compound pyrazole. Now, today we will discuss about imidazole or imidazole or glyoxylene in this lecture. So we start with imidazole and continue in our unit 4. Our next compound is imidazole. It is also known as imidazole or glyoxylene. And chemically, if we write down structure, then it is imidazole. Difference between, we show the difference between pyrazole and imidazole. In pyrazole, the heteroatom nitrogen, this and this are in position of 1 and 2. And in imidazole, it is at 1 and 3 position. 1, 2, 3, 4 and 5. This is imidazole or glyoxylene. Now we see preparation of imidazole. First of all, we see with it is prepared by action of ammonia on glyoxal and formaldehyde. Action of ammonia and glyoxal and formaldehyde. First of all, we write down structure of glyoxal. CHO bond CHO. This is glyoxal. 2 moles of NH3. For better understanding, I write down ammonia NH3 2 moles and one compound formaldehyde HCHO formaldehyde. This is ammonia. So it may be prepared by action of ammonia on glyoxal and formaldehyde. So we get imidazole. So with the help of glyoxal, formaldehyde and ammonia, we get imidazole. Now we see second preparation for imidazole by the action of ammonia and aldehyde on glyoxal of other 1,2-diketo compound. Other 1,2-diketo compound. Here we write down formaldehyde, but any other compound 1,2-diketo compound, as for example R dash C double bond O, C double bond O, R double dash. This is 1,2-diketo compound. And this is treated with 2 moles of ammonia. and aldehyde RCHO, then we get derivative of imidazole. This carbon contain R. This contain R dash and R double dash plus 3H2O. So it is derivative of imidazole. So any 1,2-diketo compound is treated with ammonia and aldehyde, it gives imidazole derivative. This is second, and we have also one preparation. Third one, imidazole is synthesized from tartaric acid. Imidazole is synthesized from tartaric acid. We start preparation with tartaric acid. Imidazole from tartaric acid. Number 3, dicarboxylic acid, COOH. It is known as tartaric acid. Tartaric acid is treated with nitric acid. 2 moles of nitric acid, then dinitrate of tartaric acid is obtained. This is dinitrate of tartaric acid. Now this is undergone by denitration, so we get diketo compound. Derivative of diketo compound. Derivative of diketo compound, and this diketo compound we rearrange it as C double bond O, C double bond O, C double OH, C double OH. This is diketo compound, and it is treated with 2 moles of ammonia and aldehyde, formaldehyde. So it is converted into dicarboxylic derivative of imidazole. Imidazole, here C double OH. This is imidazole 1, 2, 3, 4 and 5. So imidazole 4,5-dicarboxylic acid. So this is the third preparation of imidazole from tartaric acid. Now we see properties of imidazole. Imidazole is 5-member ring, simple, 2 or more heteroatom containing heterocyclic compound. 2 or more heteroatom containing in its ring structure. Imidazole is solid compound, solid. Its melting point MP is 90 degrees Celsius, 90 degrees Celsius. It exhibits aromatic character. It exhibits aromatic character and weak base. It exhibits tautomerism. So position 4 and 5 must be identical. Tautomeric substitution at position 4 and 5. 4 and 5. So we write down tautomeric substitution for imidazole. If we starting with 1, 2, 3, 4 and 5, that means 4 and 5 position. So it is alpha and it is beta. If we noted alpha and beta, and if we start with numbering here, then 1, 2, 3, 4 and 5. So this is alpha and this is beta position. So it exhibits tautomerism. So position 4 and 5. 4 and 5 must be identical. The iminohydrogen atom of imidazole. The next property we see. The iminohydrogen atom of imidazole can be replaced by metal and alkyl groups. Can be replaced. This iminohydrogen can be replaced with the metals and alkyl group. This is substituted by alkyl compound methane. So 2 alkyl imidazole is also obtained. 2 alkyl imidazole is also obtained. Now we see chemical properties for imidazole. About structure, this also. Tautomerization, its position number 4 and 5 must be identical. So for some chemical reactions, I write down imidazole in center, and then we see different types of reaction. Imidazole. First of all, we see nitration. If we treated with nitrating mixture, then we get 4 nitro and 5 nitro. For nitroimidazole, and also we get this is NO2. I write down further NO2. So when nitrating mixture is applied on imidazole, then it is introduce a 4 and 5th position. So 4 and 5 nitroimidazole obtained. Second reaction, bromination takes place. Bromination takes place or halogenation takes place in presence of chloroform. So we get 4-bromo and 5-bromo imidazole. 4-bromo and 5-bromo. If we take place sulfonation with the help of sulfuric acid, then we get 4-imidazole 4-sulfonic acid. Imidazole 4-sulfonic acid or imidazole 5-sulfonic acid. Imidazole 4-sulfonic acid and imidazole 5-sulfonic acid. Alkylation takes place. Alkylation of imidazole in the presence of KOH solution, basic solution, in presence of methyl iodide CH3I, then this imino hydrogen is substituted by methyl group and we get CH3. This is 1-methyl imidazole. 1-methyl imidazole. These are very important chemical properties. And now last, ring opening reaction of imidazole. When some reagents are treated with imidazole, then 5-member heterocyclic ring is obtained and we get non-aromatic compound. It is known as ring opening reaction of imidazole. Ring opening reaction of imidazole. When imidazole is treated with H2O2 hydrogen peroxide, readily opens the ring into form oxamide. We write down structure of imidazole. This is noted by this structure. Hydrogen peroxide. We have two reaction of ring opening of imidazole. So when imidazole is treated with hydrogen peroxide, the ring is open and to form oxamide. When ring is open, then it is breaking by here and we get this is oxamide. also we get formic acid and hydrogen. So when imidazole heated with hydrogen peroxide readily opens the ring to form oxamide. This is first ring opening reaction. We have also second one. Acetyl chloride and acetic anhydride. Acetyl chloride and acetic anhydride have no reaction of imidazole. But benzyl chloride in presence of NaOH opens the ring to form dibenzoyl aminoethylene. So we write down, we have here structure of imidazole. This is imidazole. So when it is treated with benzoyl chloride, here 2 moles of hydrogen peroxide, and in this reaction we have also 2 moles of C6H5COCl. This is benzoyl chloride in presence of NaOH. So ring opening reaction takes place. CH bond NH bond CO C6H5 CH NH CO C6H5. This is dibenzoyl diaminoethylene. And removal of 2 NaCl, sodium salt of acid, and H2O. These are the ring opening reaction. When we treated acetyl chloride and acetic anhydride, so no reaction on imidazole, but we treated benzoyl chloride C6H5COCl, benzoyl chloride, then it is, and in presence of NaOH, the open the ring to form dibenzoyl diaminoethylene. So these are the very important properties of imidazole. Here complete information of imidazole I given. Now we start with next compound, that is oxazole. Today's our second heterocyclic compound is oxazole. We discuss about furan, 5 member, 1 oxygen as heteroatom, but there are one nitrogen with oxygen is known as oxazole, and we have 2 structure of oxazole. This group of heterocyclic compound possesses 5 member ring. The ring is composed of 3 carbon atom, 1 nitrogen atom and 1 oxygen atom. So this is 5 member, 2 or more heterocyclic compound. 3 carbon atom, 1 oxygen and 1 nitrogen. This is oxazole. And if the nitrogen is present at position number 2, it is known as isoxazole. So, on the basis of the relative position of two heteroatoms, we have two oxazole. One is oxazole and second is isoxazole. So, we start with synthesis of oxazole. First, oxazole may be prepared by reaction between bromoacetaldehyde and formaldehyde. Bromoacetaldehyde. This is bromoacetaldehyde. Bromoacetaldehyde between reaction between bromoacetaldehyde and formaldehyde. NH2CH double bond O. This is formamide. Oxazole may be prepared by reaction between bromoacetaldehyde and formamide. This is oxazole. So when bromoacetaldehyde and formamide react each other, we get oxazole. Now we see second preparation. By the interaction of acid-amide, bromoacetophenone, structure C6H5C double bond O CH2Br. This is bromoacetophenone. Phenone. PHENINONE, phenone, and it is treated with alpha halogen ketone. We have compound NH2C C6H5 C double bond O. This is benzamide. In first preparation, this is formamide and this is benzamide. So we get 2,4-diphenyl oxazole. 2,4-diphenyl. 2,4. This is C6H5 and this is 6th position C6H5. 2,4-diphenyl oxazole. So when by the interaction of acid-amide and alpha halogen ketone, we get derivative of oxazole. Derivative of oxazole. We have also one preparation. So we see number 3. Preparation number 3 for oxazole. Number 3. It is prepared by the reaction between chloroacetaldehyde and urea. Chloroacetaldehyde, C double bond O H bond CH2Cl. This is chloroacetaldehyde. Right. Interaction between urea. This is urea. NH2CO NH2. Urea. When chloroacetaldehyde and urea are reacted, we get 2-amino-oxazole. 2-amino-oxazole. This is 2-amino-oxazole. 2-amino-oxazole. This is derivative of oxazole. And if we remove this amino group, then this 2-amino-oxazole is undergone by diazotization. Diazotization. With the help of NaNO2 and HCl, mixture of hydrochloric acid, maintain 0 to 5 degrees Celsius temperature. Diazotization takes place. So, diazonium salt of oxazole is obtained. Diazonium salt of oxazole is obtained. N double bond and Cl. This is diazonium salt of oxazole, and boil with ethanol. C2H5OH. Boil with ethanol. So diazonium salt remove and we get oxazole with HCl and evolution of N2. So this is the third preparation of oxazole. Oxazole is prepared by the reaction between chloroacetaldehyde and urea. Now we see the properties of oxazole. Properties of oxazole. First, oxazole is coming from, according to our classification of heterocyclic compound. Oxazole is 5-member, 2 or more simple heterocyclic compound. It is colorless liquid in form of liquid and colorless. So second one is boiling point. Its boiling point is 96 degrees Celsius. It is weak basic compound, presence of nitrogen, it is weak base, and pyridine like odor, typical smell, pyridine like odor, its odor is pyridine like odor, sorry. And chemically inactive compound at room temperature. So these are the basic properties: colorless liquid, boiling point 96 degrees Celsius, weak base, pyridine like odor, and chemically inactive material. Now we see some of reaction chemical properties of oxazole. When oxazole undergone by nitration, bromination, reduction, it gives introduce the reacting group in fourth position. So when this is oxazole, when we treated with nitrating mixture NO2 group, then 4 nitro 1, 2, 3, 4 and 5. So this is 4 nitro oxazole is present. 4 nitro oxazole. Sulfonation takes place. Then oxazole 4 sulfonic acid. Oxazole 4 sulfonic acid is obtained. It is treated by bromination or halogenation. Halo group introduced at fourth position. 4-bromo-oxazole is obtained. And if we takes place reduction of this nitro group, then it is converted into reduction. So nitro is converted into amino. 4-amino oxazole. 4-amino oxazole. And this 4-amino oxazole gives dyes. It is treated with azo dyes. NaNO2 plus HCl maintain 0 to 5 degrees Celsius. First of all, it is converted into N double bond and Cl. N double bond and Cl. And this is 1 and 2 beta naphthol in NaOH. Gives azo dyes. So preparation of azodize takes place by oxazole. These are the very important properties of oxazole. Today we stop our lecture here, and remaining compound we will see in next lecture. Okay, thank you.